through the stuff that we discussed yesterday. Tristan, you just really need to focus through that first part. So we talked about how when we have our functions that are called explicit, they're always y as a function of x, which up until yesterday, that's all you've ever worked with in math. And that's all you've ever graphed. And you should know that this is a parabola and that its derivative is twice x. But yesterday we said its derivative is really 2x times the derivative of the dx dx, which is 1, right? So those are what we've worked with. And we talked about how you can have relationships. I didn't say functions because often, and most often, these aren't. Like when we go graph the two today, both will fail the vertical line test. And usually that's what happens with the implicit. Because you have x's and y's pulling in different ways, and so it causes turns. And so we called these implicit. How did we decide yesterday what was implicit and what was explicit? Like you guys should immediately, when I say like a month from now, how are you going to do the derivative? You should go, oh, that's implicit. What will you be seeing? No, Tristan, no. X's and y's mixed together, and it doesn't say y equals. All right. So yesterday we said there is a difference between A and B. You guys, except for Tristan, should all be comfortable saying, well, that's 3x squared. We learned that about a month ago, right? This is not 3y squared. I'm going to write it because it's in it, but it's 3y squared times what? dy dx. Exactly. 3y squared times dy dx. This next one, we've taken the derivatives of sums before, but they were sums of functions of x. So this is dx dx, which is 1. We said that the derivative of x is 1, but then it's plus dy dx, which is not 1. It could be, but it could be 4 too. I don't know. What's the slope of the tangent? I don't know. Right? Over here, this one's new, so tune in if you tuned out, those of you who were here yesterday, and you're like, yeah, right? Tune back in. We did not do any products yesterday, and when we do products, you have to be careful because what rule do you always use, whether it's a product of functions of x or products of functions of x and y? What rule do you think you need to launch? You do need to launch the product rule, and it's very tempting not to. And it happened to, I'd say, 2 people in Delta Math last hour. I said, remember, I told you it's really tempting not to launch into the product rule for implicit products. So we still need to do first d second. We'd need to do the derivative of y squared with respect to x. We need to do second, and d first, well, it's dx. Yeah, that's just 1, so I'm not going to write that down, right? The derivative of x is 1. So really, we have x times 2y times what? dy dx. And most of you will just write this down. But I wrote the other one up there because I do have 3 people who are absent, and the video for yesterday, I don't have one. So I'm trying to get them kind of caught up through shorter, faster notes. Yep.
Wait, why would the derivative of y there be 2y d over dx?
This one?
No, the one before.
It is.
No.
2y dy dx.
Oh.
Yep.
So wait, what were you writing on the top there? Why does it say dy
It's
squared
the
over
derivative of y squared, which is 2y times dy dx. I said you probably won't write this step.
Okay.
You stopped writing it yesterday.
Okay.
But some people were gone, so that's why. So then we talked about the steps, which you guys were very successful in Delta Math. Tristan and the ones who are gone, who are watching the video, you'll need to read through those steps, but they practice, so I don't want to waste your time. We know that the first thing we do is take the derivative of both sides, correct? You can write it down like we did yesterday, or you can just launch into it now, because we did it yesterday, correct? So you can just say, all right, this is going to be 3y squared, but there's no variable match, so what are you going to tack on? dy dx. Some of you are tacking on y prime, which is safe in B's, but it's deadly in the word problem, so I think I would just err on the safe side and just don't write the y prime, but it does speed up your work a little bit. So that's 3y squared dy dx plus 2y to the first dy dx. What do we do with constants? They stay put, and we take the derivative of the rest, which isn't 1. It's y prime or dy dx. The only one that doesn't have the dy dx attached to it is the one where there's the variable match. So minus 2x. And this was very much like your Delta Math. So right now I'm still like, you should be going, yeah, right? But like I said, I had people absent. So yesterday we said we need to get all non-dy dx terms over onto the other side. And I asked you guys, why did I do that? And someone over here, either Carissa or Bella, said so that you can pull it out. I don't remember, but it came from over here and it was a girl. Maybe it was Krista. I don't know. One of those three said you factor it out. And I was like, exactly. Because I can't isolate it when it's in three places. So then we go 3y squared plus 2y minus 5. Are you okay, Tristan? Equals 2x. And then they all end the same way. We're still looking for the derivative. It's just now going to be a function of both x and y. So what was our last step on all the delta math yesterday? It was the very last thing you guys did. You divided by what was in the way, right? So if you don't mind, I'm just going to cross it off because I wrote it all out yesterday. And I'm going to go like this. So now if you were asked to find the derivative at x equals 4, you'd be saying, I need more information. I need to know the y because it's a function of both of them, okay? And you put both of them in. All right, now we're going to bump up the difficulty a little bit. But before we do that, we're going to make a graphical representation. So I graphed that on Desmos. I had to ask somebody what it was, Kristen, and she told me that it was x squared plus 4y squared equals 4. You might not look at that and go, I know what that makes. Some of you might, though, because you had these in pre-calc. But it makes an ellipse, which is not a function. And notice that was implicitly defined. It makes this guy, all right, that goes out to 2, negative 2, up 1, down 1. So go ahead and, by the way, does anyone have a TI Inspire in here? One, I had 2 last hour. You can actually graph implicitly on your calculator. The rest of you can't because you only have that y equals button. It's just not programmed to do it. But if you want to figure it out, I put the directions on here. I'm not going to go through it because usually I only have 1 or 2. But that's a great calculator, and you should know how to use it if you've paid twice as much for it. So you might as well use it. It does a lot of things that you don't need, but they're kind of cool. All right, so let's go back to this guy, and let's go sketch him out. So that was over to 2 and out to negative 2, and it was an ellipse, and it went up to 1. So it went, I'm going to stretch it out a little bit more. It kind of went like that. Not a function. Okay, so I can't explicitly enter it on my calculator. I can still find the derivative though, so let's rewrite it. It was x squared plus 4y squared equals 4. This is a nice and easy implicit derivative to take. So I haven't upped the difficulty. I'm just adding some depth to the questioning here that you didn't have yesterday. I'm going to write 8y, but then I'm going to remember times the derivative of the guts, and then constants go to 4. And I'm going way faster than yesterday, but you all had it except 3 people. All right, so we're going to now isolate that. We'll subtract the 2x, right? We'll divide by 8y, and that will give us, I'm just going to write y prime here because I'm struggling with space. Wait, 2x. Subtract the 2x. I said x and wrote a 1. All right, so I subtracted the 2x, gone. And then I divided by 8y. I'll simplify it as negative x fourths. And a y. Can you see that? I'll rewrite it. Negative x on the top and a 4y on the bottom. There it is. That will give me the derivative anywhere, right, around the ellipse, which is the slope of the tangent line, which when we go physicsy, it's going to represent what's called tangential velocity. Okay? But for now, don't worry about it. All right, so we're going to go down here. And now we're going to find it at a specific point. We didn't do that yesterday much, but all I need to do is plug it in. It says you do the opposite of x, so I'll do the opposite of root 2 over 4 times the y. And the question always becomes, should I simplify? And I answer that always 2 ways. I ask you a question, is it multiple choice or not? If I say not, right, leave it. Because what will happen if you simplify it wrong? You're right. But if it's multiple choice, that's where you get, where they make sure you know how to simplify, because you will not see that. So I'm going to pretend it's multiple choice because I don't even like the looks of this. Okay? I'm going to say the negatives are gone. So I have the root 2 on the top, the 4 on the bottom, and then I need to multiply by the reciprocal. So I just drop the negatives because they don't matter because there's 2 of them, and I just did the reciprocal. What's root 2 times root 2? 2, yeah. And I end up with a half. Don't lose track of what that represents. I'm going to go back up to the graph. It means at that point, which was root 2, which is about 1.4, so let's go right over here. You would be at negative 1 over root 2. And I just found that line's what? Slope. Yeah, looks kind of good, actually, from the graph. All right, so I found that line slope. Now, adding more depth to it, skill from chapter 2. We haven't done that yet in our implicit stuff, but it doesn't matter. You still need the exact same information. Last chapter, when it said write the equation of a line, which it did all the time, right? What 2 things did we need? We needed a point, and we needed the slope. It's just now, in calculus, the slope isn't m. It's the derivative at that point, which we already have. So as long as I know the ingredients for that, they're all here. It's y minus the y we know is equal to the slope there times, whoops, that wasn't my slope, is equal to the slope there times x minus the x you know. Awesome, right? Mandy, should I simplify that? No. I actually used her as my example last time. I threw you under the bus. I did. I don't know if I used your name, though. I said the little person who sits right here was in for help time correcting her mistakes. She had all her calculus wonderful, and her line was awesome. So she asked me, why did you take the point off? And I said, because you simplified it and you wrote minus 4 equal, wasn't it that? And she had like 2x, and there was a plus 2 here. And she wrote y equals 2x minus 2. But she couldn't see it because I was such a brain fart. So I said, Mandy, what's 2 plus 4? She goes, 6. I said, what'd you write? She said, oh! So that's why we don't simplify unless it's multiple choice. Because just in the rare case, it doesn't happen very often. But sometimes our brains just go kind of wonky when we simplify things. Which, like, I know she knows what 2 plus 4 is. I think, right? Right? Now I just threw you under the bus and all of you two. Oh, that's okay. Are you okay? Okay. You actually, I said you did your calculus. She just had a brain fart. All right. Next. Now we're going to really add a layer of depth to it. Write the equation above explicitly. You should know what that means from yesterday. Explicitly defined functions need to be in what form? Y equals some function of x. So that means code language, you solve for y. Sometimes you can't. Actually, a lot of the times you can't. But I put an E, pretty simplistic, implicitly defined function. It was x squared plus 4y squared equaled 4, correct? I think I've written it enough times today. Do I have everything right, or was it 4x squared? No, that's right. All right, so if I solve this, Tristan, for y, because I can, but yesterday, Tristan, we had a whole bunch where we couldn't, so we were forced to do it the above way. So what we're going to do right now is divide by 4. So let's go do that. We're going to take a square root. Let's go do that. And what else do I need to do? When I solve that, and again, I went through a class because that's algebra 1, but what do I need in front of it? Plus or minus. Okay? So let's go clean that up. My explicitly defined function is plus or minus the square root of 4 minus x squared all over 2. But I have to decide which one it is. Am I going to leave it like this, or should it be the minus part? And how do I decide that?
Why is it 2?
Because the square root of 4.
Oh, because you can take
Yeah. Yeah, I just was like, why leave a root 4 under there? Right? So, alright, so we subtracted the x squared, divided by 4, took a root 4 is 2, are we good? And somebody told me to do a plus or minus, and I'm now debating which one I need for this problem. Do you remember from yesterday? I chose the positive one because I was at the point 3, 4, where the y's are positive. I was on the top half of the circle. On this one, for that ellipse, go look at the point. Is it going to be on the top half of the ellipse or the bottom half? The bottom, right? Thank you. So this one needs a negative. I just wanted to make sure you didn't take out from yesterday that that's always the positive. You gotta go check that. Okay? So now I'm going to take that guy's derivative. That guy is -1/2, and it's 4 minus x squared under a root. I don't need to be implicit now. I can use what rule? I can use the chain rule explicitly. Wow! I just saw your umblagata or whatever that thing is called, the little dangler. What's the thing that dangles in your throat called? Uvula? That, the yours. That's the biggest yawn I've ever seen. It was like, whoa. Alright, anyway, that's on video too, but I didn't say your name. So you still are a nice fella.
Give me credit. Thank you.
Alright, so back to this one. I'm going to bring the 1/2 up front. Right? I'm going to knock the power down 1. Nice and easy. And I'm not going to forget the derivative of the guts, but it's with respect to x, and it is x. So I'm very safe and ought to and should and will write -2x. Technically dx. But we don't need to do that. Alright, what am I going to do? I'm going to clean that thing up. Okay? So, what? There. Should be a 1/4. Thank you. No, you should have stopped me on that one. The other one, that was my mistake. The other one was, what am I doing? I'm cleaning it up. Right? So I have an X on the top. What else do I have? Just an X on the top. A 2 on the bottom, it looks like. So the 2/4. Then I had a negative power, which I hate. I don't like fractions. I'm going to go like this. All right. Now here's the deal. We are at the point that was the square root of 2 comma, I don't even care. Because if I want to find the derivative and it's explicitly defined, I just need the x value, correct? So if I go plug in the x value, I'll get a √2 on the top. On the bottom, I'll have 2. And I'm going to have 4 minus √2 squared. So under that little root, it's going to be another √2. They're going to cancel, and I should not be at all surprised that I got a 1/2. The ellipse is the same, right? We're at the same point. We just found the derivative 2 ways. Does that make sense? But the minute I go mess with it in our last one of the day, I can give you an implicitly defined one that's far more complicated. That one you can't solve for y. It's not even that it's messy, it's not possible. All right? So this one you're forced to do only one way, implicit. And it's a little trickier, so focus on this one. That last one wasn't too bad. But the trickier they get, the cooler the graph is. All right? So let's go take a look. How do I find the derivative of this? I take the derivative of both sides with respect to x. Yesterday we wrote d dx on this side and on the other side, but now your brain can just go ahead and do that. All right, here we go. We have a function inside a function. We're going to chain rule it. We'll bring the 2 out front. We will knock it down 1, and then we'll multiply by the derivative of the guts. Some of you will skip this step and you'll just do the derivative of the guts in your head. But when it's notes, I kind of want to make sure when you go back, you're not like, what? And also the delta math, if you choose that, it's going to write x squared plus y squared parentheses with a prime out here. Kind of telling you that we're multiplying. You need to go do the derivative of the guts. But you probably won't do this step. On the other side, okay, what rule am I going to use? Yes, thank you. Product rule. Okay, so that's first. Actually, let's finish up this side first. I've got the 6. I've got the x squared plus y squared. You guys go write down the derivative of those guts. I put the d dx on there for the 3 who are absent. You should drop it. Like you should write this. All right, here we go. So you should have written 2x plus 2y, and then what? Do y dx or y prime, but I'm going to use the nice notation because I'm the teacher. And then you did yawn out a nice little so we'll go do that. First function. This is where I write be careful. It happened to some in the other class. I said it's very tempting to skip the product rule. I had a bunch. There's one on delta math. where it was like a 7xy. And I had 3 of them who wrote 7y prime. They did the derivative of them each. But you don't. You do first the function of x, d second. So what am I going to write? dy. Thank you. You guys got this. dy dx plus second y. What's d first? 100. I told them to be careful too, though, and it's so tempting because it looks so good just to say derivative. It really is, but it's which word did somebody use enough time? Deadly. All right. So let's go back over here. Technically, we need to solve it for dy dx. And if you do, you'll get the right answer, and it's going to be a mess. Do you see why? Yeah, did I do a mistake?
Wait, so on the
Second d first. Is that what you're going to?
Yeah.
Okay, sorry, I think I said 100y and wrote a y. All right. So, technically, the process says solve for dy dx. But do you like to work with all those variables? And there's a lot. It looks kind of like alphabet soup up there, right? Do you like to work with variables or numbers? Same here. And since I'm only doing it at this specific point, I'm going to go replace right now every x with a 3 and every y with a 1 to get rid of a whole bunch of stuff up here. I'm going to go 6 times 3 squared plus 1. And then I'm going to do 2 times 3 plus 2 times 1. dy dx is what I'm trying to figure out. I'm just getting rid of some of the mess. Is equal to 100 times x dy dx, right? Plus 100y, which is just 100. Boy, did that make it look nicer. My goal is still to figure out the dy dx. So I'm going to go back over here and make it even nicer. This is really 6 times 10, right? Do you mind if I just cross it out so I don't have to rewrite again? You guys okay with that? I'm going to replace this with its number. What do we always do when what we want is trapped inside of parentheses? For you guys, it's always just been, oh, x is in parentheses. I better do what? How do you get rid of the parentheses? Let's go back. Pretend we're not in derivative land and you're trying to solve for x. Sorry, I'm in the dead zone. You do that, correct? I'm still going to do it. So I'll still have 360 now, plus 120 unknowns. And on the right-hand side, I have 300 unknowns, plus 100. Now we're in pre-algebra, solving an equation when the unknown, which is always an x, is on both sides. So the skills you use in this class are all old. They just look different. So I need to get my unknown on one side, just like you would if it was x. So let's subtract the 120 of them, get rid of it over here. Well, 360 equals 180 unknowns. I'm saying unknowns because sometimes people don't see that as like a variable to be solved. All right, now what do? Yeah, let's move the 100 over. So we have 260 is equal to 180 unknowns. Divide by 180. Looks like I'll get 26/18. And I'm seeing that as something that can go farther, right? 13/9. Yeah, and that's what we got last hour. That does ring a bell. What is that number? I say 13/9. What I mean is, what does it represent in this problem? The slope on this implicitly graphed curve at what spot? Yeah, it's the slope of, let's go draw it. It's the slope of that guy. All right, we're done. So what are we doing next? You're going to pick. Okay, we're not doing this. We wait for after the AP exam for this skill right now. And I did the last couple years because when I threw them in and we went to distance learning the year before this, we ran out of time. So anything that's not on the AP test, I've saved for you guys. Your choice is, you're going to either work right now for a good chunk of time. It's got a good chunk of time. You have about 25 minutes. Work on the circuit for 25 minutes, or what? Delta math. I think in terms of time and difficulty, they're pretty close. They're just a different format. So I like to give you a choice. And again, you can do both. I just need the second one by Monday for extra credit. Okay. The Delta Math Level 3 is a doozy, but there's only 2 of them. Okay.
this one has a finite number of problems.
It does.
Also, I was gonna do both. So
You what?
I'm gonna do both anyways.
Oh, there you go.
I'm gonna end up doing both. So.
It's good practice, but I don't think we all need it, so.
So I
Yep.
finished my task.